Hello, Math3 Extended. This is Mrs. Bricky, and I'm just making this video for those of you who were gone or if you were in class and these were a little bit tricky for you, just to help you see sort of one example of each of our equation types from class in lesson 6.7. So first, I want to just remind you that we have solved exponential equations before. And so equations like this one on the screen, 3 to the power x minus 1 is equal to 17. We solved these in a prior lesson, and our method for solving was to take that exponential form and convert it into a log form. So for this one, if we convert that, that's going to be a log base 3 of 17 equal to x minus 1. So these two equations are equivalent to each other. And so we can, this second equation with the log, though, it just puts the x in a position where we can get it by itself easily by adding 1. So we need to evaluate log base 3 of 17 using our change of base formula right here. Our calculator doesn't have a base 3 button, so we do log 17 divided by log 3 in our calculator, and that is 2.5789. That's equal to x minus 1, and so our last step is to add 1, and then we have our answer, 3.579. So we've solved equations like this before. So today we're doing like more advanced equations. So the difference is we might have an exponential equal to an exponential where we have variables on both sides of that equation. We have also equations where we might have a mixture of an exponential and terms that don't have an exponential but still have a variable, or other types. So these ones are a little bit more complicated to solve. The first one on the left here is pretty basic. So exponentials have a 1-to-1 property, which means that if we have an exponential, base b exponential power u equal to base b exponential with a power v, then we know that those two powers have to be equal to each other. So on this first example, 3 to the power x plus 7 equals 3 to the power 9x minus 5. Well, the only way those two things can equal each other is if those two powers are equal to each other. So x plus 7 is equal to 9x minus 5. So we can solve that pretty easily. You guys are experts at solving these kinds of equations. So we're going to combine some like terms and get 12 equals 8x. And then if we divide by 8, that's 3 halves. Man, I have not made a video for a while, and I am rusty at it. Okay, 3 halves is our answer for that. Now, with equations like this, especially with exponential equations, you can definitely use your calculator to check your answer. Just type in 3 to the power 3 halves plus 7, type in 3 to the power 9 times 3 halves minus 5, and those two results should be identical. Sometimes with exponentials, like you might see sort of a difference in their decimals because, and this one we shouldn't because we didn't round the answer. We left it as 3 halves. But if you have rounded your answer, you should see that they're equivalent to each other, but it might not be perfect with that rounded substitution. Okay, so that type of equation is pretty easy to solve when you already have bases that are equivalent to each other. But sometimes we have to do a process called equating the base. So on this next example, 25 to the power 2x minus 5 is equal to 125 to the power 4x. Those two bases, 25 and 125, you probably recognize them as both being powers of 5, or you might feel that they have this essence of 5 to them. So we're gonna write the 25 instead of as a 25, we're gonna think of it as 5 squared. So I didn't change that left side of the equation at all. I just wrote the 25 in an equivalent form, which is 5 squared. Now, doing that allows me to use the rules of exponents to make this into just a base 5 exponential. So our exponent rule says if we have a base with a power that's raised to another power, we can multiply those powers together. So that's what we want to do here. We have a 5 with the power 2, and that's raised to the power 2x minus 5. Well, we can multiply those powers together. So this is going to be 4x minus 10 as the power. And now we want to do something similar on the other side of the equation. Instead of writing the number 125, we want to think about a way to write that using base 5. Well, it just so happens that 5 to the third power is 125. So we're going to replace that 125 with a 5 to the power 3. And again, then we can apply our exponent rule. We've got 5 to the third power raised to the 4x power. That's the same as 5 to the power 12x. Okay, so now we have applied our exponent properties and we have done what's called equating the base. So we turned it into this type of equation where we have the same base on both sides. So now if 5 to the power 4x minus 10 is equal to 5 to the power 12x, the only way that's possible is if the power 4x minus 10 is equal to the power 12x. So we can now finish solving this fairly easily. We get negative 10 is equal to 8x. And so then when we divide by 8, that's equal to negative 5/4. So we get our solution. And again, you can, on a problem like this, always check your answer. Maybe not a great idea on an assignment because it just adds a lot of time. But on a test, it's not a bad idea to go back to your original equation and plug in your answer and see if the two sides of the equation are actually equivalent to each other, like this. And you would see on the calculator that they are. Okay, so that was the first type. This first type using the one-to-one property of exponentials, but we sometimes have to equate the bases. Okay, the next type it looks almost identical to the ones we just did, but it's not, we don't have the ability to equate the base. So the procedure that I'm going to show you here, it would definitely work on these types of equations that we just finished, but honestly, if you can see a way to equate the bases, it's easier to follow this path. So in this case, though, with a base 5 and a base 2, I can't really equate the bases at all. So over here on the side, I have the list of the procedure that we're going to follow, or the steps that we're going to follow. These are pretty intense, though. So our first step is that we are going to take the log of both sides. Just like I could square root both sides if it was helpful, or add 2 to both sides, the thing that's helpful here is to log both sides. So this is the log of 5 to the power x minus 1 equal to log of 2 to the power x plus 3. So we logged both sides. And honestly, that didn't look like it really changed a whole lot, just literally added log to both sides. Well, now that these are logs, though, we can apply log properties. One of the log properties that we had is that if we have a log of something with a power, we can bring that power to the front as a coefficient. We're going to use that idea now. I'm going to bring this down as a coefficient, and I'm going to bring that x plus 3 down as a coefficient. I'm going to go ahead and put it in parentheses since it has 2 terms. So x minus 1 log 5 is equal to x plus 3 log 2. Okay, we have completed our first 2 steps on this little checklist. The next step that we want to follow is to distribute. And honestly, all of the steps that we're going to do to finish are steps that you have done before. Just it looks a little different or harder because two of the numbers are logs. So like log 5 is just a number, log 2 is just a number. The steps we follow are not going to be hardly any different than if we had an equation like this one right here. It's just that instead of a 5, I have a log 5, and instead of a 2, I have a log 2. So we're going to go ahead and distribute just like you would distribute in this other more familiar equation over here. So if I distribute, this is, let me put my little arrow and show you where I'm distributing. So it's an x times a log 5, and then it's a minus a 1 times a log 5. Now we don't need a coefficient 1, so I'm going to go ahead and erase it. It just looks funny to me when it has a 1 with a L next to it. Okay, and then on the other side, we're also going to distribute that log 2. So we get x log 2 plus 3 log 2. Okay, so our goal here, remember, is to solve for x. And right now I have two terms that have x's. I have an x with a log 5 on one side and an x with a log 2 on the other side. I want to get those to the same side of the equation. And then I want to get all the ones that don't have an x to the other side so that it has a form of like this. So I have all the x's on one side and all the numbers on the other. Again, it's a process you've done before. The difference here is that some of our numbers are logarithmic numbers. So let me get rid of that highlighting so that we don't have to see it. Okay, so I'm going to subtract x log 2. So this one cancels out. And then I'm also going to add log 5 so that this one cancels. So now my equation looks like x log 5 minus x log 2 equals 3 log 2 plus log 5. On the right side of the equation over here, this is just a number. You could get it from your calculator right now. I prefer to wait until the last step to use my calculator, but you definitely could. So we've distributed, we sorted our terms, we're ready to factor out an x. So notice we got all the x's to one side so that they have an x in common, and now I'm going to factor it out. X log 5 minus log 2 is equal to 3 log 2 plus log 5. And now we're ready for our last step, which is that we want this x by itself. Right now, this x is multiplied by log 5 minus log 2. So we need to divide to get our final answer. Oops, that's a plus. Log 5 minus log 2 is what we're dividing by. Okay, if you were thinking to yourself, why does Mrs. Bricky sometimes capitalize her logs and sometimes not? That's just me and my weird handwriting, and sometimes it comes out as a capital L and sometimes it doesn't. And usually when I'm writing natural logs, it's cursive. So that's just my dumb handwriting thing. There's no difference between a capital L log, and a lowercase log. Okay, so you're ready to just type this into your calculator, and I chose to use a base 10 log at the very beginning because I had a base 10 calculator button, so we don't need to do any change of base or anything. One thing I would caution you about in your calculator is that when you're typing in something kind of long and crazy like this, the calculator itself puts a parenthesis right here after log. And if you're going to type some other stuff like plus log 5 after, you do need to close that parenthesis. It wouldn't matter if you closed this one here on the end. You could leave that one off if you're like, man, I hate pushing the button. But you should, if there's one that's like in the middle of a line, you should end it. So when you type it in, in the calculator, it should look something like this. And I probably should have typed that in before so I could tell you the decimal, but I didn't. So now I got to type it in really quick. And hopefully I typed this right. Let's see. Yeah, so our x value is 4.026 if we round. You might be wondering, like, why do we leave so many decimals when we're working with logs? And that's because even a thousandth can kind of make a big difference on these types of equations. Okay, again, if you wanted to check your answer, which is a fantastic idea on a test, you could definitely sub that answer back into both sides of the equation and see if they are the same. So this equation is now finished. I think this is the most difficult type. So just, practice that a couple of times and make sure you have the hang of it. Okay, our last type are equations that are exponential, but they're going to maybe need to be factored or otherwise worked on using some of our old techniques. And using our technique of using logs is going to be the last step. So we're going to do some things to isolate the exponential before we use the log. So this first type, e to the 2x power minus 5 e to the x plus 6 equals 0. So what you need to sort of realize is that this e to the 2x, it's the same as an e to the x squared. So if it helps you to write it that way, you can. But that's what an e to the 2x is. And if you're like, man, why is that? I guess I can kind of show you. E to the x, if we're thinking about squaring an e to the x, that means it's an e to the x multiplied by an e to the x. Which means that it's an e to the x plus x, which is an e to the 2x. Or if you applied the other exponent rule, this was sort of applying like what's the meaning of squaring something, which is to times it by itself. If we use our exponent rule directly, it's an e to the power x raised to the power 2. We multiply the powers together. So, no matter how you think about it, an e to the x that is being squared is an e to the 2x. And this is also not the same as an e with a power x squared. That's a completely different thing. So make sure you kind of see the difference between those two. So we are going to be able to factor this little expression or this little equation that we're working on. And it's going to factor exactly the same way that you factor a quadratic. Like if it said x squared minus 5x plus 6 equals 0, you would be like, okay, it's an x times an x. And then let's see, we're going to use 3 and 2 with minuses, and then you would set each of those equal to 0 and get 2 and 3 as your answers. So it's almost exactly the same as that. The difference is when you are thinking about what goes in that first spot, it's not an x, it's an e to the power x. We would still be thinking about that 6 to get a 2 and a 3. And then we wouldn't be finished at this step right here. This is normally sort of where we're like, okay, I'm done. We get e to the x equals 3, and now we have an exponential equation, with that exponential by itself. We're going to convert it into a log to get our final answer. Sometimes with base e, people have a harder time converting. It is, log base e of 3 equals x, but we don't really ever write a log log base e. That's our natural log. So this solution, this first answer is the natural log of 3, which has a decimal equivalent you could get from your calculator with that natural log button. Our second factor would lead us to the conclusion that e to the x equals 2. And again, if we convert that, and we're just using zero product property here, if we convert that, we get natural log of 2 is equal to x. So our two answers are the natural log of 3 and the natural log of 2. And you could get the decimal of those in your calculator. Okay, I wanted to show you one last one because factoring factoring can be done in tons of different ways and tons of different situations. It's not always that we have sort of a quadratic type like this one. Sometimes we just have to notice what two terms have in common. This equation says x e to the x minus 7x is equal to 0. You notice that the two terms have an x in common, and so we can factor the x out. So this is x multiplied by e to the x minus 7 equals 0. Factoring, remember we want that 0 there because we want to use the zero product property. The x here tells us that x equals 0 is one solution. Our other solution is that e to the x equals 7. So that one we convert, and it's the natural log of 7. So our two answers are 0 and the natural log of 7. And again, you could get the decimal from that, from your calculator for that. So, okay, so those were our 3 types for lesson 6.7. So the type where we might factor or otherwise work on the equation and then finish by converting into log form. We've got the type where we can't equate the base, so we just go on this really long journey to our answer, and the type that we started with where we are able to equate the base. The method here will work on these ones if you forget how they work. Okay, that's it. Let me know if you have any questions. Happy to help out. And yeah, that's it. Happy weekend.